So we're on our last day of derivative rule properties, and then tomorrow and through the rest of it we'll talk about derivative applications, and then that will close up reviewing derivatives. Integrals, we only have 2 or 3 days to review because we just did them, and then we're literally just going to hammer through 5 for 5s, FRQs, and we'll do something that we did today where you take your FRQ and then grade it. I may also give you FRQs in class, give you 15 minutes, and then collect and grade them. Because the only way you're going to improve is if you see exactly how they would be graded on the AP exam. So in this unit, our objectives are continuing to look at differentiability and continuity, ending with product quotients, composition, and implicit. So the reason we do implicit before we do related rates is because you need related rates and implicit differentiation to go hand in hand. This part of the AP exam, Unit 3, is about 10%. So again, you're seeing that each unit is about 10%. The big units are going to be 4 and 8. You need to know your definition of the derivative, but again, it's typically a multiple choice or an application. So the limit as sine x plus h minus sine x all over h, taking that into consideration and finding or identifying the pieces, what is f prime? Well, this is the definition of the derivative up here. Then its derivative would be cosine x. So the derivative would be cosine x. And you didn't have to work out that limit. What you would want to know is that f of x is equal to sine x. So that f prime of x, if it was multiple choice, would be the derivative of sine, which is cosine. So in number 2, similar follow-up, but now you have the sine at a point plus h. So f of x is still sine x. F prime of x is still cosine x. But now we're looking at f of x and f prime of x at a point. And that point is 5/3. So then you have to take the cosine of 5/3, and that would be your final answer. And then the last one, exact same problem, exact same answer. However, this is the formal definition of the derivative, and this is the alternate form of the derivative. So again, in the alternate form of the derivative, the first piece is f of x, the second piece is f at a, and then it's over x minus a. And then you would be finding your derivative at f prime of a. Remember that differentiability implies continuity. Continuity does not imply differentiability. A function is not differentiable at C if we have a whole, an asymptote, the left-hand limit does not equal the right-hand limit, or if C is undefined. So in the scenarios in here, we talked about continuity. Today, we're hitting differentiability. So we know that it's continuous if it's smooth and goes together. It's not differentiable if we have holes, asymptotes, left-hand limit not equaling right-hand limit, which we would see with a cusp or a corner. So where is the function not differentiable and why? Where is the function not differentiable and why? So the one everybody misses the tends to miss is the one there because you have that vertical tangent. So it's not differentiable at 2. You have a vertical tangent. It's not differentiable at 4 because it's not continuous. And it's not differentiable at 5 because you have a 4. The chain rule pops up with tables. We're going to look at tables. A lot more tables. Chain rule pops up with tables. Wait, Brandon's on his 1 number problem. What did you forget? The derivative of the inside. So it's outside times derivative of the inside. So then filling in the boxes on that next problem. The inside is the 4x squared plus 3x. The outside is the 5. So it'd be 5, 4x squared plus 3x to the 4th times 8x plus 3. Derivative of 4x squared is 8x. Derivative of 3x is 3. Next problem, y equals sine x cubed. Outside is sine, inside is x cubed. Derivative of sine is cosine. So again, the x cubed stays. And then you multiply by x cubed to derivative of x cubed to get 3x squared. So you get 3x squared cosine x cubed. We learned this year that not all equations can be put into y equals, that we have something called implicit differentiation, or we have functions that are explicit and implicit, meaning that you can solve for x or you can solve for y, and then you have problems where the x and y will always be stuck together. On the AP exam, if you have these types of problems, you are looking for keywords. So in the AP exam, you know a problem is implicit if it has the words with respect to. That's that WRT that I put sometimes. In an FRQ, you are often given the answer and asked to show that derivative. That was one of our, we didn't add all this up. That was one of our points from earlier today, right? That very first FRQ question was, you were given the derivative, you had to show it. Oftentimes we will see those with differential equations and slope fields. So that's a differential equation slope field style question. These are examples of implicit. They're implicit because here you have a 3x, y all being multiplied, but you also have x and y here, so it's impossible to get the x by itself or the y by itself. If you have something inside a trig function, that's going to be implicit if they're mixed variables. Or out. Alright, find your derivative, but this is the one I was mad at because it's there. So I'm going to try it on your own, at the bottom, or in the blank spots up top, or on the next page. One, two, the problem, but that's not good to me. Okay, and then after you're done, you can obviously check it because you have the answers. So after you're done, go ahead and check it. You have the answers. The last thing we want to talk about is inverses. I know that we hate them. So derivatives of inverse functions come from function composition. Remember that inverses means to switch x and y. So if you usually have dy dx, then we are finding dx dy, essentially. So again, we usually find dy dx, we're finding dx dy. Oh, really annoying. There's more on my side that's not showing up. So if f of x is equal to the point xy, then g of x is equal to the point yx. So then if you're looking for g prime of x, it's really like dx dy or g prime of y. So if the slope of f of x is equal to dy dx, then the slope of g prime y would be equal to dx dy. So if you think about this, if you're looking at g prime of x, that's equal to 1 over f prime of g of x, but g of x would be really equal to x, so it's kind of like looking at 1 over f prime. Alright, homework is just the multiple choice and effort here at the end of your packet. There is not very many and it is not very long.